Our next speaker is Mei-Po Kwan. She is a visiting professor in the Department of Geography at the University of California, Berkeley.
Thank you.
And adjunct professor of epidemiology and biostatistics in the School of Medicine at the Case Western Reserve University. She's also currently the editor of the Annals Association of American Geographers. Mei-Po has received numerous awards, including the 2005 University Consortium for Geographic Information Science Research Award. She has received numerous grants totaling over $18 million from the National Science Foundation and other granting institutions. And she's published over 100 publications in journals and about a number of books and other things. So welcome, Mei-Po Kwan.
Yeah, thank you. Can you all hear me okay? Okay, good, yeah. Well, I mean, today Michael Chow began his talk with apology. I probably should also begin with a similar apology that, I also attend the same workshop, Cyber Infrastructure and Health Research, organized by the AAG, and in 10 days ago, so you may have seen some of the slides. And however, some are different. So, today what I'm trying to talk about is a topic that is related to the analysis of human space-time behavior, which is when I always think that when you add human into GIS analysis, and it's kind of complicated, quite a lot of things because people are quite unpredictable usually. And since the big data challenge can be really a lot, and I'm going to focus mainly on 3 aspects of it. The first one I would like to think about is, the activity patterns of a classification and clustering research area that we may have some implications for cyber infrastructure and vice versa. And also the second one is to look into geographical context and the identifications of it. And lastly, I would like to look into the private protection and data confidentiality as part of the cyber infrastructure in a cyber GIS. Because when we have cyber GIS that is necessarily have locations, and they're highly sensitive, when we say locations are powerful, they can also negatively impact on people when the location is reviewed. So for example, after San Diego, after this wonderful workshop and also, good restaurant meals and with a whole bunch of colleagues. And actually I went to Tijuana and all my colleagues in San Diego, they say, no, don't go to Tijuana. There's a lot of gang shooting and we get killed or they're really big guys, So I mean, okay, well, I still went and walked actually every single streets in the red light districts because I have a project in the border on female sex worker and their HIV risk. So, and then I also look into the drug addicts and the injections and how they inject drugs and everywhere, and then see how they, actually, their face all swollen, when you see them. They were really beaten very hard. And then a woman can come, in front of us and screaming, and all her property, like clothes and everything, her belongings actually were taken just a while ago. So I'm thinking to myself, and I'm thinking, oh, these people are not going to give us location data. They're not going to let us track them, or even tell us, where they go. Actually, the adaptive strategy of this vulnerable population, what they do is that they're trying to hide their location. They try to move, almost every day to a different residence. So they actually don't have a residence. If you ask them, they're moving around every day to have a different pattern. So the police and other people will not beat them up so hard. So so I think that that's why I'm thinking, if we're thinking about building a cyber infrastructure, cyber GIS, for vulnerable population, for very sensitive health data, and also for even, like human trajectory data, and what kind of privacy protection and data confidentiality that we need to give them, because we are more thinking about, you're sending some requests and putting some data, combining, integrating in somewhere that is pretty mysterious, to lots of people, like maybe in Illinois, Urbana, Champaign, somewhere in a supercomputer center. And then we're sending requests But would people actually give you the data to be stored? And would researchers who collected that kind of data actually trust it? Actually, I sign a lot of agreement, data agreement, and also contracts when I have to use those data. The worst one is actually we have to keep all the data within a four wall, and it cannot go out. And the computer that we're using cannot have any media to copy anything, and there's no internet. So how can we, analyze those data and also still be able to, and at a very precise level, even though our data collection actually can collect very precise information. So recently, my collaborators at AAG and also U of Michigan and I were awarded a grant, to really addressing this issue in a technical and managerial way, and we are trying to find some solution to this, to looking into whether we can build some infrastructure that can have protection for this very highly sensitive and highly intensive data. So maybe if I have time, then I'll talk a little bit about that. Let me look at my time in my phone. Okay, so. So we have a lot of data, like parcel data, transportation data, environmental data, land use, land parcel, land covers, and also most recently, I think that everybody has been talking about, now people are carrying their phone, right? So we pretty much can give them a phone or pretty inexpensively collect a lot of, so-called the GPS data. This is a Lexington, Kentucky, with a whole bunch of people, mounting a GPS on their car, moving around in 7 days. So this, and then this is every 10 seconds, there's a data point. And the third dimension is pretty much, what is it? Is 7 days, time. And yet, with so many data intent, still you can say, with a couple of thousand people a week's GPS collection is still not very big, right? This is the characteristic. You just don't get a lot of, very personalized individual data when you have the GPS. Even with the GPS, the volume is not very large. But I'll tell you how does it relate to cyber infrastructure. So, this is the same data. And then we can see quite a lot clear patterns, in GPS. And however, when you combine it with all the environmental data, in any intersections of any resolution, for example, every 10 seconds and every minute, every 10 minutes. And then if you combine those data, and you can analyze a lot of information of this human trajectory. However, this data integration can be cumbersome, data storage, and also the time. It doesn't have to be 7 days. It can be really, really long time. Now, since there are lots of different kinds of data available historically and also in the future, we can obviously plan to collect all this. And when we look into visualization, something that we do pretty well in a GIS, and we can analyze a large complex data set. And it uses very quantitative data, but pretty much the researchers can also have an interpret mode of the analysis. And what we can do is generalizing patterns, right? And retaining the particularities of the individuals. So what is difficult in a human activity in space and time is that it doesn't just have the location and time which the GPS can collect, right? So it actually have location, timing, duration, sequencing, types of activities, who are you with, what kind of trips, what transportation mode. You can get add-on to all this, characteristic. We call this more like a component or composition, kind of characteristic. Each component is quite important. For example, however, largely ignored is also a structure of those trajectory data. So because we have, a lot of people collecting tons of those data, but they actually don't really know what kind of question you can ask, right? So one question that is actually quite important is that in this trajectory data, there's actually a structure, a structural characteristics of it, which is like mostly can be analyzed using the sequencing. For example, I always give an example, and one time I gave an example about should one buy ice cream before they go to the gym. well, I mean, obviously, if you buy the ice cream and go to the gym and you don't eat it, then it'll melt, right? And if you if you eat it and go to the gym, and it kind of destroy the purpose, yeah. So after I gave that talk, like Matt Wilson actually from University of Kentucky actually tweet, to the web, I guess Twitter, and then everybody is saying that Mei-Po Kwan is saying that you should buy ice cream before you go to the gym. So I think that this is what is well, I mean, they got from my talk, I guess, yeah. So the sequencing provide you like a structure of a trajectory of a people's daily life, and that is actually quite important if you think about health implication, because if you're always thinking about people are going from their home, and that is actually where you're going, and actually and go to a screening, and then thus hoping that the accessibility are related to their home, it may be all wrong, because people may actually go to screening after work. And if you don't have facilities after work, then you may actually get the whole pictures out. So this is another one. And another one is the so-called interdependency among all these attributes, yeah. Because I don't think people kind of like to think about the location and time in human activities in space-time, right? Space and time, right? But they kind of forget about actually all these dimensions have interdependency, and this interdependency actually are important. For example, with certain activities can be undertaken in a particular location, it needs to be taken into account. And these are more complicated because it's also the contextual elements of all these trajectories that we need to be thinking, such as gender, race, income, and disability, because health outcome, social science, or different human behavior and their outcome are not equally applied or gender among gender, race, and income, and different kinds of social differences. They're actually quite differentially impacted upon, and that's why disparity can be a key issue. Like health disparities always is a big one. So how does that account into our analysis? It's all kind of complicated, and this makes the simultaneously analysis of many dimensions difficult. And usually people use multivariate grouping method, and however that it discretize space and time. So I mean, they pretty much group space and time into a particular intervals, and thus also missing quite a lot of the dimensions. So well, I mean, then what should we do? Obviously, the so-called I did a lot of activity-based modeling before, and then it's pretty much in the transportation literature. And what they do is also looking into using statistical modeling, also quite ignoring the space and time, and mostly and at the most like discretizing those dimensions. So I mean, one solution is that we can think about a problem. For example, to think about in human activities behavior is that activity pattern classification. And this is a problem, is that when a large number of space-time paths, which is actually combining so many dimensions, that you can do, obviously 3D geovisualizations, we look into patterns, but when there are lots of them, people obviously have a cognitive barrier. And so how can we derive a relatively smaller set of representative activity patterns from data, from all these individual type of data, for example, from diary, from GPS tracks, and there's obviously spatial data mining techniques such as k-means clustering and hierarchical clustering algorithms. However, those really also are not very satisfactory kind of means. So another thing is that you can also compare individual activity patterns, derive so-called nearest measure, and look between them. So pretty much you're measuring the distance between two space-time paths, which is actually quite multidimensional, and group the individual with similar activity patterns, and to derive some representative aggregated pattern. But due to all this complexity and the multidimensional characteristics, it's also pretty much a major challenge. My former PhD students, Guo Shangding and I, think about maybe using a multidimensional sequence alignment method, and also with the help with Ning-Chuan Shao, and thinking into a multi-objective evolutionary algorithm to classify human space-time activities. And pretty much, the sequence alignment in multi-dimension would derive, what is the, measure the nearest, and between the pair of individual activity patterns, and the other one, the evolution algorithm is trying to minimize the cost of it. Well, pretty much you encoded a sequence of updates activities like this of one person, and then I'm not going to explain this, but it's just the basic idea is that we are aligning sequencing using the minimal number of characteristic additions of operations and minimizing the distance score. So that's the whole idea of it, right? So it's kind of straightforward. However, you doing one dimension, doing each dimension separately and aligning them is actually not very difficult, but doing multi-dimension is quite difficult. The order is in black, but it's when you do unit sequencing of length n, then you actually have a pretty high order, and there's a lot of possible alignments, and even with the length of 15, and thus it's a very difficult to exhaustively search to find a single alignment and simultaneously minimize the score. So that makes me think about, like if we have all this, trajectory space-time data exploring, people are more willing, to carry a phone like this and giving you the data. And when we want to actually classify, the patterns, and then we, in a cyber infrastructure, maybe there's somewhere there's some computer, if I have, might ask, what will you do if you're unlimited computing power? I would say, can I, actually at least, look at a descriptive activity pattern, analyzing them, using more multidimensional, not just one dimension or just two dimension, but more dimensions in looking into classifying of the space-time path with all this dimensionality. So this can be one. And the other one, the second challenge that I would say that is also for CyberGIS and cyber infrastructures is so-called identification of the context. In a lot of social science and health geography, we look at the individual's characteristics, but we also look into the so-called socio-geographic context and also the environmental factors. However, when we look into social science or health research, and that is just identifying the individual characteristics and come up with a context is not enough, because we always have to link it to behavior and then also eventually to outcome. Like whether getting close in the built environment, getting close to a bike path, whether does it lead to walking, more physical exercise, and eventually getting to less possibility of getting diabetes. Actually, it's a pretty complicated process, and we see very inconsistent outcome in the literature. And so context is quite difficult. I would say that it is a problem. Usually we identify like a causal pathway, but this is actually one of the ones is actually to looking into so-called the contextual variables, and is eventually looking into the behavior of quitting smoking. However, constructing a conceptual model that specifies the causal pathway among the contextual attributes and outcomes, and looking into how this contextual units or geographical area for evaluating individual exposure to this contextual influence are then identified. And again, effects on the outcomes by social and physical environments are also often inconsistent. And when people come and ask me, why is it my result doesn't show that the geographic or physical environments are coming up, showing up as important, and I would ask them, how do you think about identifying your context? Is it just around the home, geocoded the home and get the census tract out of it? And that might be a little bit artificial, because people usually don't know which census tract they live in, and this is a boundary that is pretty much not decided for studying the research questions that you're asking. And so, a lot of research are also quite inconsistent, like the food environment. People say access to the grocery, can get you nutritious food, and thus, and people when it's not accessible and they have a bad health outcome. But actually the intervention, so-called putting a corner store, actually doesn't really help either. So does it matter or does it not matter? So actually that leads me to think about a really important problem, and actually other than the modifiable area unit problem. Because the modifiable area unit problem is really looking into the zonal scheme and the geographical scale. When you're actually more varying your zonal scheme and geographical scale, you may get a different result. And however, I have a very forthcoming article which actually attracting, it's not in print yet, but people must have seen it in cyberspace, and they kept on emailing me, asking me about this problem, and it looks like that it's getting a lot of attention, and which is talking about when the geographical context is affected by the spatial and temporal uncertainties. So when we don't know the spatial and temporal uncertainties, and then we may identify not the right context. The effects of area-based attributes on the individual behaviors may be affected by how contextual units or the neighborhoods are geographically delineated and the extent to which these areal units deviate from the true geographical context. So people usually look into the home of residence as the neighborhood or the geographical context or the contextual influence, and thus make a lot of influence. However, well, that might be not true, that the home may not be the space, like the actual area that exerts the contextual influence on the studies. And also the timing, right? We can always say that, cancer, but cancer doesn't develop in one day. And obviously, your immediate residential location may not have any relevancy to the timing of or contributing to the disease. So the temporal uncertainty in the timing and duration individuals actually experience this contextual influence is also uncertain. And thus, when we have, why this is significant is because this is a methodological problem, because it means that analytical results can be different for different delineations of contextual units, even if everything else is the same. So also from Michael Chow's talk and a few others' talk, that people are thinking maybe a cyber infrastructure can now simulate and experiment different scale. For example, we can say GPS, you can have different spatial temporal resolution, and we can experiment that. And to the extent that the cyber infrastructure can experiment different scales, and actually I would think that CyberGIS and cyber infrastructure may well be experimenting what is the geographical context that may actually exert the influence. For example, you can get into all kinds of influential error when you have the contextual effect wrong. It can be a false negative or false positive, and that's why in the literature we always found geographical environment kind of inconsistent result, and we're scratching our heads, and is it true, is it not true, is it good, is it not good, and I would think that this is actually some experiments. For example, some of my recent research is experimenting all this by just looking into the composite depredation index, which is more like a contextual variable. What this is actually just a composite index of disadvantages. For example, poverty, unemployment, vacant lot, and all this, so-called depredation in a neighborhood that might exert a contextual influence on behavior. And then I did, a circular buffer around participants' home addresses. I do have a mile-row network buffer among the participants' GPS tracks, and also did the minimum convex polygon. And looking into depredation index, they're all pretty much significantly deviant from the home census tract. And so that means that all this, may have contextual influence. This is more like the home, around the home with activity space. This is the GPS track with the buffer. And so, and all this behavior, I just started with when you add behavior, when you add human behavior, everything has just got more complicated. For example, adolescents' risk behavior, like substance use may be influenced or not only by socioeconomic depredations, but also by interacting with friends and peers in various non-residential contexts. And the boundary of these multiple contexts are often difficult to clearly delineate, and also even when they can, some of them may not be continuous, or it can be really discrete contextual areas. So we may be, we might probably have to experiment something other than just an area or a polygon, because, this is a real data from Indianapolis, with a whole bunch of collaborators, and Reals is obviously one of the lead one, and then what we find out, the neighborhood data identified can be linear, can be actually something a long time ago in the childhood. She played with the grandma. She played basketball in the grandmother's home. So the time can be really uncertain. In terms of the context, not the immediate time, and the space actually is quite far away from the home. So because if you think about the actual areas of here, and even the shape doesn't need to be a polygon, and it doesn't have to be contiguous. This is the neighborhood that all these teenage girls are telling us about the neighborhood boundaries. So that means that, actually that is more complication. It's not just multi-level, but it's multi-scale, and may operate, in a block that people may reside. Some may operate in a larger area, school, and store and institutions, and then it really makes it complicated, and sometimes can be nested or overlapping in a complex manner. So people move around also, it's dynamic, and during the course of the day, and then also the physical and social characteristics of neighborhood may change, and then also governments, people's action may change, environmental influence may change. And then that leads me to think about, that we need a new conceptualization of exposure and context that really taking into the actual spatial and temporal configuration, quote and unquote, of exposure and context, and look into where and when the people spend their time that is different from individual, and then all this individualized measure can allow the exposure level to vary even for individual within the same neighborhood or place. And obviously, so this is all obviously, needs to be, I think that, a whole bunch of simulation may also be useful. Another one is that what Luke Genselin today talked about the real-time context, and he actually talked about the real-time decision making. But a lot of we use GPS data to delineate activity space would represent a significant step towards identifying the dynamic context, but some health behavior are affected by situational contingency. Because it can be real time, it doesn't have to be just static or even, dynamic, like in a day or even a year or a couple, tens of years. And it cannot be captured by the GPS data alone. For example, a particular situation in real time may promote, substantive use depending on who is with him or her. For example, friends or parents. It's the same context, like a movie theater with friends or parents can be very different. Yeah, I guess with parents probably not using the substance use. So what is this context implication for cyber infrastructure? Is really to looking into since this is so uncertain, and this is a huge problem. It looks like it's similar to MOB, but essentially it's different than MOB, than the modifiable area unit problem, because we are not thinking about just scale. We are actually identifying what actually exerting the influence, which is actually can be with all this fine, refined spatial and temporal data. I think that we can actually got to the more precise one. Okay, the last one, so cyber infrastructure, I think that can also may play a role by looking into to help us to find those relevant one. The last one is that the small but relevant data. We talk about big data a lot, lots of data, right? But a lot of vulnerable population like in health, I just talked to Judith yesterday, and then the population that she works with is, she's in social work, and the population and social groups that she's working with is actually highly vulnerable. And then they, obviously, when they think about location, they actually have a lot of emotional attachment, and also she told me that actually they may have, after talking about it, they may have to go to therapy. I mean, because it's really powerful, impeccable on their experiences, how they experience. And so is the female sex worker in the US/Mexico border. And actually, when they are, getting out of the license, sex work actually is legal in Mexico. But and again, when you got no money, actually the license is very expensive. And when you get out of the license, you actually can be harassed by the police, and then you got to move around the location. Well, if I like when I'm harassed or getting attacked, I obviously would also try to move around and try to hide the location. So actually the location or places of certain individuals, when they actually try to hide the location or do not go and cannot go or fear to visit, actually it can be much more important. And those population are small but relevant, because eventually it's this female sex worker who got afraid of going to get resources and health services and get infected the HIV, and they are much higher risk. And eventually, because their work nature, and they actually got the disease. Actually, there's small population, but the disease can really widespread in a really big manner. So they are the populations that most likely that we want to study, and especially if we care about disparities, inequality, environmental justice, and all this, So they either do not want to disclose their location as a way of protection, or they are masking or moving a lot, in order to be an adaptive strategy. The researchers are pretty limited into use the data in a physical location, because you really cannot, get it out. So this is the collection and use of this enormous amount of more precise and accurate data can also contain information on geographical location that raise concern for data confidentiality and personal privacy. The spatial analysis and mapping of this individual data can also help identify important geographical patterns or lead to significant knowledge for dealing with special social issues. But disclosure of the locations of the subject's home, workplaces, data activities, or trips, and may lead to serious negative consequences. And I have a lot of experience in working with this data. Every data I work with is, so a lot of them are pretty vulnerable populations that needs a lot of potential protection, not only if their names cannot be revealed, but also their maps and the location and the trajectory. And all this cannot be even, taken out of a four-wall room. And also, that makes the analysis pretty difficult. So for example, if using this kind of survey data always raise important issue, how do we protect the privacy of an individual, or even how to get them to give you the data? And even if you get the data, you really don't want to just disseminate them using a cyber infrastructure, CyberGIS, just because we want to share data. So this is a significant problem in building so-called the community, and also the capacity for very big data, or so-called the data-intensive research, especially when you add human into it. And even the normal daily life, may not be easily reviewed by many people. So, and there are different methods of doing it, and geographical masking, that you are specifically in introducing some noise or deterministic noise to the original data matrix, for modifying the geographic coordinates of the data points, and also masking them in a particular location is also maybe one of the ways. And we can use aggregation, affine transformation, random perturbations, and all this. And then another way is that, that we are trying to experiment with U of Michigan, is that trying to provide some, management system and using an infrastructure to manage all this very, very sensitive data. And obviously, we are just in the beginning, and we'll see how that would works. I think since Lynn is cutting me, so I'm just trying to say a few words and saying that the key challenges can be Well, human data doesn't have to be, may not be very big in volume, but what we really need is bigger ideas, bigger questions, to be able to answer new questions. And when we think about big data, we need to have relevant data, and what is relevant is important. And small data can be also relevant, so it can be used in concurrent. And the spatial context, we always think about what is geographical context and spatial context. And then I think that it really needs to be building up using, hopefully more computing power to build it to be a more causally relevant spatial temporal context. Because if geographical context needs to be, I know that a lot of behavioral scientists are very interested now into spatial and geographical context, but it needs to be showing more linkages, to the behavior and outcome. And lastly, obviously, I would like to conclude with that the data confidentiality is a very important question that any cyber infrastructures need to be thinking. If you, are thinking about individual level sensitive, like space-time data. All GIS deal with space and time, right? So it is. CyberGIS by definition is included space-time data. So, and then if you want to look into human and manipulate those information and analyze those information, and I think that data confidentiality and privacy protection needs to be a high priority. And thank you. All ready for dinner already? I guess we are hungry. Yeah, Tim? Nah.
Yeah.
Mei-Po, for the idea of context, there was a lot in spatial context in particular here, there was a lot of geometry that was in that context. Is there also other dimensionality of context? Let's say, since we're dealing with geometry there, topology, connectedness, things that influence other things that may not be dependent on distance and time in particular. Such as an example here, you gave the example of the young girl who was playing basketball at a grandmother's house, but this person could have also been involved in a cyber stalking kind of situation here. In the framework that you're developing, is there a capacity to involve other dimensionalities of that context as well?
Yeah, sure. I mean, I think that obviously this is a very good question. I think to look into, actually the health scientists are really just geocode the location and trying to either do a buffer of a certain distance, network-based or Euclidean-based, or that census tract or block group, and you identifying that. And we are extending the ideas to be, more multiple contexts that where the trajectory that they are going, right? However, I think that you're right, that it's still dealing with geometry, either a point, a line, a polygon. I think that, one of my attempt recently, actually in the female sex worker project, is trying to use geonarrative to identify something, which is, important, either culturally, institutionally, or the memory, what the memory would serve, like the grandmother's backyard, which is she played basketball. And that is actually something that, from her memory. And then I think that if you want me to give more example, I can certainly give. And the geonarrative is actually to looking into by narrative analysis, inquiry, to look into what is important events, in the persons, especially in space and time in mind, because it's geo, right? I mean, otherwise it's not just called narrative analysis. And then to identify what is the important context, and especially in terms of space and time. Yeah. So that is one of the ways. I'm not saying that this is the only way or there shouldn't be other ways. That obviously needs more to identify, because I also agree with you. We tend to be, the easy route would be to create geometry, to, deal with this, But it shouldn't be like this. And another way is that obviously we can ask the subject, the participants to draw, to draw the areas and talk about that. And there's another way of eliciting the context. But there may be other ways too. Would you suggest any?
Any other questions?
It's a modeling issue is what it is, because what we saw there is a fairly easy model to develop. But if we look into some other ways for modeling approaches, a network modeling kind of approach there, where you could assign any of the linkages to a dimensionality, and then distance becomes something else in terms of closeness.
Oh yeah,
Family
you can
relationship
modify.
kind
You
of
can
thing. Some of
definitely use those transformation and in the GIS and do more, manipulate the, manipulate the topology. But another thing is that I think is also maybe important is people's daily life. Yeah. That we can elicit. For example, the space-time constraints that people face. That's actually giving a structure to the trajectory or space-time path, as you say, right? I mean, if you really think about it, yeah, and then people are limited by the space-time constraints, and by developing the potential path area, we're actually giving it a structure. So that is also maybe one of the other ways, yeah. And it's
Okay,
based on
let's,
geocomputation, obviously, yeah.
Shaolin? Again, thanks to Mei-Po.